Okay, hi everyone. Thank you so much for joining us today. It's great to see a lot of people come together for such an important topic. And also, just an FYI, we're also streaming live on LinkedIn. So, hi to everyone who's joining from there. Today, we're going to be talking about haptics and VR specifically within the healthcare sector. Gijs will show some very interesting use cases, giving highlight to how SenseGlove has been involved, but also just the importance of haptics in general. So we'll go through a presentation, and please feel free to send questions through the chat while Gijs is speaking. Just an FYI, please don't use the live call function just because it'll affect the quality of the streaming. So we would really appreciate it if you sent it through chat form. And our very special speaker today is Gijs, the co-founder and CPO of SenseGlove. So I'll give the stage to you now.
This is Chloe, and wonderful to be present. Well, to present you in the first webinar that we host. So if things don't go that smoothly, it's our first time, so bear with us. So as Chloe mentioned, I'm one of the co-founders of SenseGlove. I'm currently responsible for product development, production, and people, and also special projects. So that is the CPO role of mine here at SenseGlove. Feel free to interact with me during the presentation in the chat. I will go over 6 topics, and after each topic, I'll pause my presentation to have a little bit of interactivity with you guys. And I will be talking firstly, really shamelessly, on SenseGlove promotion. So what are we doing here? Then I will look into more haptic training use cases for the medical industry, haptics in rehabilitation. Then I'll talk a little bit about fun and other inspiring concepts and use cases that we've seen using haptics in the medical environments. I'll promote a little bit of the Dutch program we do here in the Netherlands. And then lastly, I'll give a slight introduction of, okay, I might be very enthusiastic about all these use cases, but how can I implement haptics into my use cases? And give a slight stepwise approach on how to do that. So let's start with the first topic, the shameless promotion of SenseGlove. So what we do here at SenseGlove, obviously we are always connecting to a XR, virtual reality, augmented reality environment, spatial computing environment, name the buzzword that belongs to 3D computing. And you see that you can fully have like a full 3D vision of everything you can see with headsets like the VAR. You can see in full HD. And also with spatial audio, you can hear where a sound is coming from. But as soon as you're trying to interact in that virtual environment, you feel yourself either holding a controller, like those HTC controllers you see here, or in best cases have hand tracking and grasping in thin air. So that interaction part really lags behind with the other senses that you have as a human. And that's where haptics comes in play. So haptics, quote unquote, allows you to feel in virtual or in 3D computing, virtual reality or in 3D computing. So basically, and at SenseGlove, we always talk about hand haptics because that's what we do. So there are 5 ways how a human perceives touch, and there are technologies behind that can let you feel those type of senses that you, or those types of feedback you want. So first, if you see your hands, if you're engaged with your hands, if you believe that your own hands, or that the virtual hands that are tracked are your hands, you kind of have an idea of what you're about to touch. And that feeling of proprioception already gives you an idea of what I'm going to grasp. And then as a human, you can feel textures, and you can feel like button clicks by little hairs on your skin that vibrate with you, and your brains can interpret that as a texture. You can simulate that in a technology that's called vibrotactile feedback. That's a very familiar technology. It's in every smartphone out there today, and has been implemented into ways of type of actuators and in ways of feel that you can get out of it. A little bit more scarce in a sense, but also something that already exists quite long in the robotics field, is something we call force feedback. And that allows you to feel kind of the sizes and the density of an object, because your brain can interpret the actual muscle contraction that you have, so the amount of muscle contraction, and can make sense whether something is hard or soft or small or large. And obviously also weight is part of the force perception, but that's not on your hands, but that's on your arm. And also your skin has little receptors inside it that can deform, well, that can measure how much your skin is deforming. And with that, you can actually feel the shapes of objects. So whether it's a round edge, a soft edge, whether something is square or is a round part. And there are several ways on how to get a user to feel those type of things. So for instance, there's a company called Haptics, or a project that Meta has been doing, that blow up little air bubbles inside your hand, and by the deformation that those air bubbles give you, you kind of have a notion of what type of shape there is. But there are also like objects that, like a research project of little balls that press against your skin. And with our Nova 2, we're also trying to mimic a little bit of contact feedback in the inside of your hand by just having a strap that presses against your skin with two little outstanding vibromotors on it. And obviously, lastly, you can feel hot and cold or temperature, and you have temperature actuators, and it can be electronic temperature actuators, but it can also be um, cooling and heating of water, for instance. We've seen research projects in that. And then you might think, where is pain? Pain is just too much stimuli of everything. And in that sense, you can also simulate pain by just doing too much of everything or a specific part. At SenseGlove, we try to make hand haptics scalable because especially force feedback exoskeletons and bigger, like more complex haptics parts have been around since the 90s, but it's never been into a form factor that you can actually use it in daily life, or you can use it in like daily activities, such as together within VR headsets. Like VR also was there, quite bulky, quite expensive technologies, and when Oculus really made that into a standalone wearable device, you see that VR really took its flight. We're actually doing the same with haptics, and in this case, we try to always embed as much as fidelity into the haptic products that we have, but we always are looking at something that is user-friendly, that is easy to use. So the product offerings that we have are spread out in three different sections. First of all, we have our haptic force feedback gloves with our Nova line. I will talk about that a little bit later on the next slide. But secondly, what we also do is we're creating now the technology that we have inside the Nova, so the wireless communication, the battery management, the haptic drivers that in there. We're creating that in order we're taking that into like 3D printed or props in order to also get that contact feedback or the shape of an object right. And that is in particular at hand when, for instance, a virtual reality training is fully focused around one type of product or one type of tool, in a sense. And lastly, we have our force feedback exoskeletons that are more precise, a little less user-friendly in a way, but therefore are very suited for telerobotic control. And we'll be working on a next iteration of that, because obviously the DK1 as we have now is not for sale anymore. So with our SenseGlove Nova, and I'm highlighting then the two already was mentioned with the palm strap, we have created a wearable glove that you can just don and off within like 2 seconds, 10 seconds of calibration, and you're good to go. And with that, we embedded force feedback, so you have the sizes and the densities of objects that you can feel. We have embedded vibrotactile feedback and little simple LRA motors on the fingers where they can only vary in amplitude. And we have a more complex motor in the hub of the hand that can have like a wide band of frequencies that it can give to you, and also quite strong in amplitude, or also in amplitude, but also strong in like the forces that it can give. So you can make a lot of varieties of type of tactile feedback on that. And obviously we track your hands and it's fully wireless. So that's what we do. And that is also where I will be talking about why at some points you need a glove and why another solution is more interested for the use cases, especially in the medical field. So any questions so far of the shameless promotion of SenseGlove that I did and a little bit of explanation of
chat, but as of
the
now,
products
I
that we
think
have.
we're all good on questions. Yes.
Then let's move on. So I already talked a little bit about terms as fidelity and in terms of cost and so on. But you can see, especially in medical training or in immersive training in general, several levels of type of solutions, haptic solutions that you would need in such a training use case. And I want to talk about three terms here. First one is cost. You all familiar probably with that. That is the price of a total solution. Something that you might be less familiar with is called haptic fidelity. That has to do with those sensors of touch in a way. So how realistic is the touch that the device is giving to you, the perception of touch that you feel. And then there's haptic transparency, and that is how many different type of simulations can I get into a system, but also how less restricted am I if I'm using the haptic solution. So those are the three terms that I will be briefly discussing also during when I show the use cases. And for medical training, you may basically have immersive medical training. So for VR, AR type of solutions, you have basically four different sections. One is just familiarization training. If you have a simple procedural training. So either you want to know, you want to get people familiar with a certain room, or you want to let them know how you can move part one to part B. You probably won't need haptics for that to get a good learning retention of that particular training. If you do that with controllers, you're good enough in a way. But when things become a little bit more complex, so there's a lot of, for instance, there are tools involved, or there is a certain way how you need to position something, you would rather have something that mimics your real interaction. So not probably your real feeling, but a little bit of your real interaction. And that's where gloves like the SenseGlove Nova are very useful to do so, because those force you to have an interaction that is similar to your real life interaction. The product won't feel that way, but at least your interaction is similar and you create kind of your muscle memory. Well, then, if you come to really like more complex procedural or gross motor skill training but you want to train more scenarios. So for instance, I want to do a minimum invasive surgery training of a larger group of people. Then you have kind of generic grounded devices. So it's like the little robotic pens that you have, or you can create like we do, like haptic tools, haptic props that help you to use one particular type of tool inside some more complex skill or more complex procedural training. And then if you really want to look specialized training, I will show something like a simulator where you can only simulate the use of a dental drill in a sense, but you really want to have the specific feeling of that particular part, then you have to create a specialized haptic simulator. And obviously the fidelity increases, the cost increases over time, and the haptic transparency decreases. So you have to think of what is the actual use case that I'm trying to do and what is the haptic tool that I want to use there. So as a good example of a very specialized training is this device made by Sim2Care. They created a trainer or haptic trainer combined with like an AR environment, where if you have the dental handpiece, if you want to use that, you want to drill in some teeth, you want to learn those skills, you want to see how precise you can do that. Really, the haptic feeling of what you get from this machine is one-on-one matching with the feeling you would also get when you were drilling in someone's real teeth, or when you were cleaning out someone's real teeth. Obviously, you can only train the procedures or train the skills that have to do with the dental handpiece on this machine. That's quite a lot for dentists already. But if you want to do minimal invasive surgery training with this tool, you won't be able to do so. You need to buy a whole new trainer. You need to make a whole new simulation tool for it. And the cost of those devices are also quite expensive. So remember, the fidelity is extremely high. It feels super realistic. It's super costly, but you cannot, well, the transparency in that sense is pretty low, because, well, you have obviously a very bulky device, so you know always I have to use that device, and there are limited use cases that you can simulate with this device. If we go to another use case that is built by Haptic and a VR company called Fundamental Surgery, you see that they use the Haptic Inverse 3, which is a joystick you see on the right, force feedback joystick. You see that they have now created training environments where you can do like basic surgery practices, like making an incision or collecting some tissue samples. But you see already with those two examples, those are two different types of training, two different types of interaction, two different types of skills that you can learn with this particular haptic tool. So the fidelity might be not that big as that high as you have with the dental trainer, but the transparency is way bigger, because, well, you can do two types of simulation training already. Obviously, you have different software, but with the Haptic tool, yeah, you can do those types of training. So there's a medium to high haptic transparency, and also the cost of such a device is way lower than a like €100,000 costing Sim2Care device, where Haptic is around €3,000 for one part, and if you have two hands, it's around €6,000. And then, like a third way of delivering, having haptics inside your VR training is with SenseGlove Novas. And this is a training made by MedVR, or e-learning design center. That's kind of their main brand. And what they do like a lot of different type of VR trainings for nurses and then operation room assistants. And you can see here one of the modules that they've made for the neurologist to do a neurological assessment by patients. But they also are now making 100 different type of modules using the SenseGlove for different type of procedural trainings for nurses. So in that way, you see, again, the transparency is way higher, because yeah, you have a glove and a headset, and that's all you need, and the software can then determine what type of interactions you would give in there, and what type of trainings you can build in there. But you still, well, the fidelity is obviously also lower, because, well, you have only the force feedback part on the hands, and it forces you to have an interaction that is similar. So those are a little bit of the trade-offs and the type of fidelities, transparencies, and costs that you can build into trainings for the medical sector using.
Yes, so we have some questions from the
Any
previous
questions
topic that came
related
through
to
from
those topics
LinkedIn, so it's a bit
before I
more
move on
specific to
to
SenseGlove.
the topic of rehabilitation?
First question is, does SenseGlove only support PC VR, or also standalone such as MetaQuest, Pico,
Yep.
or HTC?
We do support all standalone headsets, so the SenseGlove connect via Bluetooth. We do support all standalone VR headsets, so the SenseGlove connect via Bluetooth, and has also an Android, an Android builder into it. So if you build with the SenseGlove SDK from Unity or Unreal, you can build for Android. So it is compatible with all standalone headsets. You have to then have some form of tracking where your hands are in space. That's mostly done by slapping the controller on top of it. We have mounts for Oculus Quest 2, Oculus Quest Pro, Pico Neo 3, and for the HTC Vive tracker solutions, so the wristband solutions, if you're looking at the Vive Focus 3 or XR Elite. So those are the headsets we support. Unfortunately, not yet Pico Neo
Great.
4
Then we
because
have
the
two
controller is
questions that
way
go
too
hand
big
in hand. One
to
is about
strap
the
on your hand.
duration of the battery,
But we're
and
hoping
another
to
one is
get solutions
can we
for
know
that
how
also.
long we can use it, and does it have a potential power drop, the glove?
So the battery life is around 4 hours of normal playtime. It would be an hour if you would be squeezing a stress ball all the time, but that's not usually the case. There is no like force power drop over the time, so we get that within the limits of the battery. If the battery goes below 20%, obviously the there's a little bit of power drop. But yeah, then also the blink light on the
Ooh, there we go.
the
We also have two
back of the
messages
glove turns
now
red, so
about
you
the
know you
current
need to
topic
charge
we've
it.
been talking about. So the first one is, you mentioned minimally invasive surgery a few times. Do you have any examples involving the Nova gloves in that field?
Yeah. No, we don't have examples involving the Nova glove in that field, and I also do think that in most of the cases, solely a Nova glove is not suited for that, because what you want to get out of that is more touch-based feelings that are related to the actual tools that you're using, and those come from those are forces that come from a grounded surface in a sense, or a grounded, inside a patient in that case. So you need to have some haptic device that is grounded to a table, or that's grounded to a chair or a floor. And in that case, for instance, the Happily Inverse 3 would be a better haptic device to use for that. Obviously, you can combine it. So you have, if you wear the gloves, you can still interact with the pens of the Happily 3, and you can also like 3D print the actual tool on top of it. We can also help with that if you would like to have some help on that. And then as soon as you get your hands off the Happily, in a sense, you still are able to interact with other objects in the virtual operation theater that you have to get to, for instance, pick up your scissors and so on. But for the actual
Another
procedure
question
or
from
actual
Lisbeth.
skill training of
Do
minimal
you
invasive
have an
surgery, I would
indication on
not advise you
adoption
to
of
use
these
only
scenarios in the
SenseGlove
medical
helmets.
sector? And have you seen these used outside the training area in the medical sector?
These scenarios are focused on training. Well, these scenarios are focused on training. There's a reason why they're in the training blog, obviously. The SimToCare dental simulator is very well implemented into dental care. If you're at the Octa here in Amsterdam, you'll see around 20 of those simulators. You have different hospitals using them as well. With the Happily and fundamental surgery case, it's getting there. So there are like a few hospitals that do pilot projects now with these type of tools. And with the tool from Italy Design Center, we're scaling up to around 100 hospitals now that can potentially use this solution. So it's really into an implementation phase. You see the first pilots of those last two use cases that I mentioned are successful. And are now
last question we've got is,
get their
hi,
implementation in daily
have you done
practice.
any research in validating the amount of force required to simulate palpitation forces of various anatomical structures? Anatomical structures, sorry, I butchered that a little. Yes. Have you done any research in validating the amount of force required to simulate palpitation forces of various
Can you repeat that
anatomical
once more?
structures?
Because No, we have not. I do know what you mean with that. But if you're looking at like kind of joint palpitation, there's also or well, joint palpitation might be not the right term. So maybe also to emphasize on that, I'm not a medical specialist. I'm a haptic specialist, so I can interpret things wrongly in a way. So don't blame me on that. But no, we have not done any research on that as our SenseGlove team, because it's also not something that I again advise to do with SenseGlove only. We do when we're designing virtual reality trainings, or when our clients are designing virtual reality trainings with our gloves, always incorporate user studies and user feedback in it. So it's also not that we kind of measure all the time the type of forces that are needed and build that into the virtual training. Sometimes we do, but let's say in 80% of the cases not. What we do, we design it from what kind of feels good, and then present that to the user groups and see whether they have anything to add to that. And that's once again also not to simulate the full feeling of the actual skill that you want to train or the actual procedure you want to train, but it's to force the trainee to have an interaction that is similar. Remembering also back to the other question, are these also use cases that go beyond training? Yes, for instance, the use of our gloves inside procedural training for medical devices is also being used for actual marketing or acquisition of customers. So think of like a large MRI scan. You don't have to take that part to a business fair in order to show how the system works to your new clients. You can just take a set of VR gloves and headsets and showcase it that way. That's a way more convenient way of showcasing new products that you want to bring out, for instance. So besides that, those
Great.
use
That was the
cases
last
can be
question for this round.
done for training, to train people on how to use the equipment. It can also be used for marketing. Awesome. Then let's go into haptics for rehabilitation. And there again, also the amount of fidelity. I don't want to talk about that too much anymore. But I think you get the concept now that you have to think, okay, what is the outcome that I want to achieve? What is that a way of learning? Is that the skill that I want to learn? Is that a procedure that I want to learn? Is that in the case of rehabilitation, what is the state of the patient, and what is the desired outcome of that particular usage of the technology? And think of that first, and then select kind of your technology next to it. So I'll give you two use cases. One is full like assist as needed robotic training for patients with acquired brain injuries, so stroke patients, most of the time. And this robot is developed by Tyra Motion. It's called the Amadeo robot. And what it does, you can, if you have a paralyzed or partly paralyzed upper limb, hand in this case, the robot, the trainings that are provided are kind of, repetitive motions, and if the virtual environment in this case is a flat screen, asks you to open and close your hands in very repetitive motions, and is combined with some type of gaming in a sense. And it can assist, and the robot can assist you in completing those full range of motions. And that is helpful in very early phases of recovery. And if you are at kind of very severe damage of the upper extremities, or the hand in this case. And what the haptics part of it is that the robot itself feels how much force the actual user can deliver, and can assist the user to fully complete the motion. And the idea behind this is that when you are able to fully complete the range of motion of your hand in this case, you're re-triggering your brain on how to learn to reuse your hand again. And what you see here on the screen, then you can make that interesting by playing all type of games. So once again, this is a very bulky and complex device, but gives you a lot of freedom in actually helping a patient to regain motion in a very early stage. Whether if we look at a project that we're currently doing with the random Erasmus University here in Rotterdam, we are looking at a patient group that is way more, that has already way more motor function and needs to do more occupational therapy in order to be able to live on their own, for instance. And in that way, we've created a virtual reality environment, which is resembling a kitchen. And you need to practice all type of tasks of daily living. Doing that in VR helps patients to feel safe. Well, if you would drop a real cup of coffee, or you would drop a real coffee can, or you would using like a real cooking environment, you would always need to have a one-on-one therapist next to you, because well, you might drop things, you might be in danger of cutting yourself, and as we know, there's a lot of scarcity of time of physicians, or in this case, occupational therapists. So what the idea of this environment is that you can have multiple patients in a group setting training occupational tasks, like in this kitchen environment, but only having one therapist at the time. And that saves a lot of cost that actually saves on having therapists there, and also allows your patients to train more, because they don't have to wait until a therapist is available. And we see now there's a lot of improvements that need to be done in this scenario. But what we see now is that patients can actually be trained without one-on-one supervision of an occupational therapist. And we're implementing those improvements as we speak. So there is a researcher mapping out all the improvements that need to be done, and from there on we'll make those improvements. But there are already two setups being used now with the researcher there in that research part in 3 days throughout the whole week, and we can see that the patients actually can train those occupational therapy without any supervision at the same time, one-on-one. Any questions so far to this two rehabilitation cases? And they're both for stroke patients, because that's where a lot of the research currently lies. Obviously, there's also a lot of other acquired brain injuries around. Other diseases is also for more children parts, but there is a little bit less research on, and there's also less research on haptics and VR involvements of the training of more acute accident, training after accidents with, for instance, your hands, or rehabilitation of that, because there is
we have not gotten any questions.
In practice, just more budget available topic, or more self-learning capabilities of the patients available. Then let's move on to some other interesting use cases we've seen in the medical field, using mostly our SenseGlove products, and it's just to showcase to you. So this is still with our old DK1, but Procter & Gamble also updated the scene also to the Nova. But I think this is a super cool movie to show marketing campaign of Procter & Gamble about the symptoms of nerve damage, or neurobion as they call it. And what Procter & Gamble wants is to create awareness of this particular type of nerve damage, because they obviously have medication. If you take that in an early stage, it slows down the process of deterioration of this disease. So they wanted to create an awareness campaign, and with the gloves, they were actually able to let you feel how it would feel if you would have that particular nerve damage in an early stage. So that's what they did, and they created a nice marketing campaign around it. And we've shown this all over the world. So our employees flew to Brazil, to Portugal, to the Philippines, and showcased this experiment throughout the whole world.
Strap it to your hand. You should be ready to go. With this, you'll be able to move around virtual objects. Give us your honest opinion.
Oh my god, this is so real.
7! Yes! Come on, let's go for 8. Let's give you something else to try.
It's not gripping as good as the first time.
I'm trying to grab, it's not letting me.
I cannot feel anything. Oh,
It's not really allowing me to like really feel the piano. No, this is like really not functioning properly.
my fingers, they are shaking.
So what we did, the people can try the gloves as like first, totally everything is working fine. They can interact in this environment as they would normally do. But then we put on the symptoms, and the fingers start to tingle. You feel a little vibration on your fingertips, and sometimes when you try to grasp an object, you won't feel anything at all. You don't feel the force feedback. You will grab through the object. Sorry, we're really moving to the next slide. And in that way, people feel the difference between a real life situation, the real life interaction we have with the glove, and with symptoms that are actually built into the glove. And you can kind of empathize with patients who actually are suffering from that neuropathy, peripheral neuropathy. And another use case, which is way different than the previous one, is in telerobotics and has to do with a lot of like more lab environments. In this case, we've done a interesting setup together with a research organization here in the Netherlands called TNO, and we've built a humanoid, bimanual humanoid robotic setup where you can control two robotic grippers, two robotic arms from a distance, and you can have very precise interactions with that robot inside, for instance, a nuclear environment, because you can place the robot there, and you can obviously not place a human there. And in this case, we did mimic nuclear decommissioning tasks for the making of medical isotopes. So to have also in a more safer environment to when something happens, decommission that particular reactor. And the interactions were so precise that you could actually take a swab and clean a little container with that swab, and you actually were able to control that robot quite precisely because of the haptic feedback on the arm, but also obviously on the fingertips, with the force and vibrotactile feedback that's available in the SenseGlove TK1. And once again, that's me operating this particular robot. And you can see how precise the tasks are, that I can do this 9-hole pick test, I think it is. So it's even a rehabilitation test. I can do that with the robots that I'm controlling with my hands. And I have a 3D vision also from above. What I see through the VR environment. And the nice thing about this setup, for instance, is also that there's something called obstacle avoidance, so you can not bump into objects that you did not select, so you cannot do any more harm to the already damaged environment in a way. then you would, if you would.
Yes,
bump
we have
into,
one specifically for the
if you won't have
PNG
that
video.
selected
Jerry
pose.
asked, how did you create the
Any
sensations
questions
for the previous video, PNG?
towards this topic? Yeah, so how we did that is by patient interviews. We had 5 patients suffering from peripheral neurobion, and we interviewed them. What are you feeling? How does that affect also your interactions in daily life? And from that, we built like a first scenario of type of feelings that we got. We also let them feel it. And we did another revision of that.
Right now.
That became the symptoms that we have in there. Then move on to something super exciting what we're doing here in the Netherlands, because especially in the Netherlands, but also in more other Western countries, we see the lack of skilled nurses, anesthesiologists, assistants now really becoming crucial, because not all the facilities can be used anymore or because of the lack of staff. So there need to be a lot of staff trained. But the current way how staff is trained is a full on-the-job training. So you're actually taking away time of the staff now to train the new staff. So you're making the situation even worse to eventually make the situation better. And that is quite a big problem, especially for nurses, for the assistants of the OR, and also for anesthesiologist assistants. So here in the Netherlands, we said we want to retrain like 50% of those trainings on an off-the-job simulated training. So 50% will still be on the job, but 50% should be in a form of simulation. The initiative was initiated by the 6 academic hospitals in the Netherlands, and there are around 40 private partners, and also the education institutes of nurses and anesthesiologist assistants are now present in this consortium. And the Dutch government granted us with 48 million to start for the first 2 years, drafting a curriculum of it, and in total it will be 84 million. And the nice thing about this is that we don't want to change anything in the education. We just want to use the same learning models called APAS as there are now. But of that whole list of APAS, what we did, we list them off. Can this be done virtually? Can this be simulated? And to what extent can it be simulated? And then once again, if it says, okay, this can be simulated, what type of simulation? Is it kind of a low fidelity simulation? Is there medium fidelity simulation? Is there high fidelity simulation? For the low fidelity simulation, no special trainer has to be built. That can just be like VR with controllers, can be even 3D video, can even be like on a tablet video. For the medium fidelity, we have 2 other options. Either you want to create like realistic interactions with SenseGloves, with SenseGlove Novas, or you want to bring it a little bit more further and have like a combination of a more specialized haptic tool like the Haptic Inverse 3 or a specialized creator dummy. And there are also even things we cannot train with those medium fidelity simulators, and a special simulator has to be built for that specific APA. And yeah, then we ask, well, over the next coming years, those APAs will be published, and the consortia and also other partners worldwide are asked to create simulations that actually can help the students to train those specific skills that they would normally also train in the APAS. And in that way, we can slowly get the digital curriculum running side by side with the actual training on the job, and slowly replacing, we hope, 50% of that. So that's a very nice initiative, how simulation and also haptics in that can help to solve this current problem we have of scarcity of staff in the medical sector. And well, the reason why I'm telling that, SenseGlove is one of the private partners who is initiating this. But if you want to learn more about it, I can bring you in contact with everyone who is actually in the team doing this on a daily basis and not being a partner of it. So let me know if you're interested in knowing more about this initiative. And obviously, you can also go to the website, and maybe Chloe can paste that in the chat here. It is Dutch opleidingen, which is education in the Netherlands.nl. Oh, and I even can paste it in the chat here.
Yes, we have. Oh, let me pull it up.
Any questions with regards to this
From
nice initiative?
LinkedIn. Oh. Yes, from LinkedIn, Mohammed asks, how do you select which simulations to develop?
Yeah, so that's kind of a public tender. So every APA will. Yeah, so that's kind of a public tender. So every APA will become a tender. Obviously, we, as the central team, made the list of type of APAs and then separated that into where we think simulation can be used, and then a public tender will be written out, and then companies can apply. Hey, I can make the simulation with this fidelity, with this haptic transparency, with this cost, and then the team will evaluate which proposal suits the best in the learning curriculum. And obviously, there will also be a total system surrounding that. There's a digital infrastructure.
Great. Then another
that all
question
those,
from
APAs can
LinkedIn.
also be
Jeffrey's
published
asking
into
if
that
we will
digital
also use
infrastructure.
UWE physical simulation.
And can you be a little bit more precise on that?
We're waiting maybe for a bit more specification. Because he also uses Dutch opleidingen. I think I'm pronouncing that right. Okay.
We'll come back to
Yeah, we'll come back to that question. Then here we have Jose from Barcelona says he's a medical researcher using VR for some education and healthcare projects. And he wanted to ask if you have any use cases evaluated, not for surgery, but for instance, in the use for children or young people when using simulations for like soft skill training.
No, as I'm not aware of that. So there's a huge lack of involving younger generations, like children in this sense, in simulated VR for a medical scene. So I have not had any, especially one using haptic gloves for that.
Okay, that
So,
is all the questions for now.
plenty of opportunities in that field, I would say. Then let's move on to the last topic of today, and that is a little bit guidance on, okay, now I've heard a lot, I've seen nice examples, use cases, I've seen about SenseGlove, but how do I implement this actually? And it's really kind of easy 10-step approach. First, you need to define what is the objectives of your use case. So even in the sense of training, what do I want to learn? What do I want? What type of learnings do I want to let come across with a simulation? And then once you know that, you know your kind of use case objectives, you can sketch, okay, what interactions are then in a scenario if I would train this particular situation. And if you have, and that you really can do that like with visualization. You just make like sketches of, okay, and now I'm picking up a coffee cup. Now I'm drilling into something, like really make that visual. And then define per interaction the haptic objective. So what should the technology bring you in that particular interaction? And for instance, if 99% of your interactions don't actually matter how they are being done, but there's only one interaction that's super important that need to be learned right, you can think of using a haptic prop for that, or you can think of using a very specialized simulation tool for that particular one interaction. But if you say, okay, like a lot of my interactions are important, but it's not really important how you grip it, how the feel feels, then you can think of, okay, then for instance, haptic gloves are a more suited way to go for. So sketch out then also those haptic interactions. So say, okay, I want to feel vibrations here. I really want to feel texture here. I really want to feel the sizes and the stiffness of an object here. And well, if you make that, you can map the technologies over that like haptic interaction map you've made and see whether you can align it with a haptic tool that's on the market, or that you need to create an own haptic tool, or that you can combine things together. And then, really choose your own tool set that you want to use in your simulation, and then start prototyping it. So don't make things really beautiful at the beginning. Don't start with nice visuals. Just take your interaction, go to like a simulation environment like Unity or Unreal, make primitives, build like simple boxes, simple not simple looking things, and really build your first interaction and iterate on that. And then obviously detail your scenario with like multi-sensory information, like nice visuals, audio. Don't forget also haptic cues. So for instance, if someone does something very well and you have a vibration motor to your disposal, just a little bit buzz of vibration. Hey, I completed this task. Helps people a lot to understand those 3D environments better. And then once your scenario is up to a level where you think, okay, now it's understandable for a non-XR or non-VR expert, bring your users as early as possible in and see, okay, hey, you're now you need to do now from the neurological assessment, that's called stem work. I'm not sure what the English term of it is. And you need to feel the vibrations of that. Is that indeed on a frequency that is usually also normal in your assessment? Does it feel right? Those type of things you only learn from the actual people who are need to be trained for those situations, because you don't know as a developer. And once you have gathered user feedback, you've implemented that user feedback, then think of how you deploy the scenario. And that can be distributing it to a content training platform, or a content management training platform, or having it local on devices. Maybe you want to also have multi-user interaction into that. So think of a way how you then deploy your scenario in a successful way. Also monitor the success. And well, then you can kind of make that loop all over again for a next scenario, or if you have deployed your scenario and you want to go back to like from step 10 to step 9, that's also a lot of iterative movements that can be done in there. So that's a little bit of also the way we work with SenseGlove. Sometimes in a very early phase, we also see, okay, we might not be able to fit your need as a tool. Your interactions are way too complex for SenseGlove Nova in this case, or are very precise, for instance. And in that way, you don't buy expensive tools. You don't invest a lot into your process of creation, because that's obviously also hourly expensive, and then most of the time in that case it has a cost. And you can make in an early stage already the good decision of what type of haptic tools to use. And if you want to know more about that, our marketing created a nice haptics checklist based on a book I co-authored together with Chris Ulrich, Eric Vasali, and Rafał Pieski from Actronica. And a little bit of nice visuals and a summary of that is in that ebook. And I think with the QR code and clicking on this link, we cannot to Riverside, but at least scanning the QR code, you can get a free ebook of that.
I'm not seeing any right now.
Any
but just
questions on the total
we've sent
webinar
the
that
link
we've
through, so
given,
you guys can just
or
click that.
on the steps of implementation?
I think maybe we'll wait a little bit if a question comes up. But
Also approaching the end of this webinar, so therefore it's now time to ask all the questions that are still in your mind.
I think we have a question coming. Yes. Jose asks, he wanted to ask about how it would be to get some piloting for the use that he mentioned. So for training children or young people when it comes to soft skill training. And he also asks, is there any collaboration program? Yes.
Let me ask in the order of questions. There are ways. There's different ways. It's also how you actually see your end solution. So obviously, I can only speak for SenseGlove. For the other solutions that I mentioned, please talk with the companies building those haptic solutions. But for SenseGlove, there's a way to pilot a 2-week trial. So if you would like to know how to do a little bit of development and you think that can be done in 2 weeks, you can request a trial in our sales and marketing team. Then we can send you a Nova 1 for 2 weeks to borrow, including obviously access to all the SDKs. Then you can see whether the tool is useful for your situation. If you think you would need longer than 2 weeks to evaluate, we can always talk, but then we advise you to buy a first development kit of our gloves, and obviously we are fully available for support. And if there's kind of a research program that we have where we align on a topic and we align on kind of a research outcome, well, not to say a research outcome, but a research question that is being researched with the gloves in our case. And if that aligns to the company interest, then we can give, for instance, bigger discounts on the gloves, and in some very rare cases, provide gloves.
And if you guys have any other questions or more specific, you can always email info@senseglove.com. I'll send it through the Riverty chat, and I believe it'll be sent in through the LinkedIn chat as well. Okay, I think we've got time. We can squeeze in one last question from Andreas. He asks, are the tendons in the Nova gloves stopped by a break or similar, or are they actively controlled with motors? And then the second part to the question, how does the stiffness compare to the DK1? When they lock, how much further does the hand close due to elasticity?
They are in the Nova. They are similar to the DK1 in brakes as a brake system, so a passive force feedback system. And due to the fact that you don't have an exoskeleton that runs through with the wire where the wire runs through, there is indeed more elasticity. So although the forces are similar, everything is perceived as a little bit softer because you have a little bit of play in the system. Because we only also break 1 degree of freedom. Coming to the Nova 2, similar setup, but we work on the accuracy of the finger tracking and therefore have better control over the simulation side of it. And also we increased the force with around 20%. So now the force resistance is about 20 Newton, and it's at minimum at 22 in the Nova 2.
Okay, I
But
said that was
we
the last
see
question.
that most of the breaks that we can achieve are around 25 Newton.
Sorry about that. We've got one question as well from LinkedIn. They ask if there can be any issue with
You're
a
muted
particular
there, Chloe.
sensor, would it affect the overall performance?
Yes, so if there is a issue with a sensor in the SenseGlove, definitely it affects the overall performance. So